today we will discuss and implement about our project, a hospital management system. Our team consists 3 members: MD Mehdi Hassan, MD Mufassal Hussain, Abhay Das Rahul. Here we have made a scenario based on blood management system. Like we have entities, we have made some entities and attributes, like the donor entity has donor ID, name, blood group, address, etc. as attributes, and the blood bank info entity has bank ID, bank name, address, city, contact number as their attributes. Like this we have another attributes and entities. From based on scenario, we have made a blood bank management system, and we have made the entity and attributes, like the donor entity has attributes like donor ID, donor name, blood group, donor address. Recipient has recipient ID, recipient name, blood group, recipient address. The blood bank has attributes bank ID, bank name, city, contact number, address. The donation has attributes donation ID, blood group, and donation date. And the blood request has request ID, blood group, and request as their attributes. And based on our scenario, we have made a relation. From this we can see one-to relation lies between donor and donation. The blood bank and donation has one-to-many relation. The recipient and blood request has one-to-many relation, and the blood bank and blood request has one-to-many relation. From the scenario and our relations, we have made an ER diagram. So we can see from this ER diagram, the donor and donation has one-to-many relation. Like this, the blood bank and donation has same relation, and recipient and blood request has same type of one-to-many relation. And here is our ER diagram to relational schema. Here the donor entity has attributes like donor ID, donor name, blood group, donor address, and the primary key is donor ID. Donation, here we can see donation ID as our primary key, blood group, donation date, and donor ID as foreign key, and bank ID as foreign key. Blood bank, from blood bank we can see bank ID is primary key, bank name, city, and address. This also lie in blood bank. From blood request, we can see request ID is our primary key, and the other keys are blood group, request date, bank ID, it is foreign key, and recipient ID, it is also foreign key. Recipient, from recipient we can see recipient ID as primary key, recipient name, blood group, and address. Contact number, from this relation we can see bank ID as foreign key and contact number as another key. And now I'm passing the floor to my another teammate named Abhay Das Rahul.
Hello, I'm Abhay Das, and I will be explaining the normalization process of this relational schema. Now that we have made the relational schema, we need to normalize the relations to remove the unnecessary redundant data. To make the normalization much easier, we denoted the attributes and relations into some easier terms, such as we denoted our entities as R1 to R6 and attributes as alphabets. For donor ID, A; for donor name, we named it B, and so on. Now we have rephrased the relations, which will be much easier for analyzing. Next, we have to find functional dependencies from each relation. For relation R1, which is for the donor entity, we have written here that B, C, and D depends on A. If we look at the table and see this entity, we can see that donor ID can be the only unique attribute for this relation, and each ID will lead to their respective name, blood group, and address, which concludes that the functional dependency is valid. We have concluded such operations for each of the functional dependencies. To reduce redundancy from the relations, we decompose these relations into their highest order normal form, starting from the first normal form up to BCNF. We checked each relation's functional dependency. If they are already in the highest order normal form, such as R1, they don't require any change. But as for R3, as it is not in the highest order normal form or BCNF, we decompose it further. Currently it's in second normal form, so we decompose it further. As for R3, we can see that it's in first normal form and second normal form, but it's not in third normal form, and definitely not in the BCNF normal form. So we decompose it further. We decompose it as R3.1 with K, J attribute, and R3.1 with HI and K attribute. Then we checked for dependency preserving decomposition, which says that functional dependency of the subrelations are union of the initial relation's functional dependency, which is satisfied in this case. Further, we check for lossless join decomposition, which it satisfied. Thus, we can make sure that this is in the highest order normal form. After every iteration, we get the final normalized schema that include the unchanged and decomposed relations. The implementation of the final schema will be conducted by Mehdi Hassan.
My name is Mehdi Hassan. After decomposition, this is our final table. Here, donor table has donor ID, primary key, D name, blood group, D address. Donation has donor ID, primary key, blood group, donation date. Here donor ID is foreign key and bank ID is foreign key. In blood bank location, address is the primary key and city. Blood bank info, where blood bank ID is the primary key, blood bank name and address is the foreign key. Blood request, where blood request ID is the primary key, blood group, blood request and bank ID is the foreign key, request ID is the foreign key. In recipient, recipient ID is the primary key, our name, blood group, our address. And contact number has bank ID, foreign key and contact number. This is our SQL query. Using this, we add this code in XAMPP, where create database management system, use database system and create table donor, where donor ID is the primary key, D address also. And the recipient, create table recipient, where recipient ID is the primary key. And also this is the blood bank location ID, where address, primary key and city. And the blood bank info, where bank ID is the primary key. Here foreign key is the address, and contact number, here bank ID is the primary key and foreign key bank ID also. Donation ID is the primary key and donor ID, bank ID is the foreign key. In blood request table, request ID is the primary key and bank ID, recipient ID is the foreign key. This is our database table, where there are 7 tables like blood bank info. Here is the blood bank info table. And blood bank location, this is the blood bank location. Blood bank request, contact number, donation, donor, recipient. Now I create some query like how many donation has each blood bank received. Now create some query. This is a query for how many donation has each blood bank received. And here left join donation ID and bank info. Left join using left join and group by bank blood bank info dot blood bank name. This is the query result. And the name. Now using query, I find list of the recipient who request O positive blood. This is a query from where we inner join blood request and inner join also recipient ID, where blood request dot blood group equal to O positive. This is a result. Thank you everyone.